In this section, I will introduce the commercially available products under the name optical flowmeter. The optical flowmeter is available for single-phase, two-phase, and three-phase applications. Its legacy name is RIOS, so we sometimes call the single-phase meter as RIOS 1P, the two-phase one as RIOS 2P, and the three-phase one as RIOS 3P. The origin of the word Rio is Greek, and it means flow. The hardware of the optical flowmeter is different for each of these categories. The single-phase meter is called the velocity meter, simply because it does measure velocity only. So there is no speed of sound sensors in this version. And typically, the speed of sound sensor array occupies a longer length in the tubing. So because they are not present, this meter is shorter in length. It's good for injector applications, water injector, gas injector, or water alternating gas injector. The PT gauge comes as an optional gauge in this meter. But if the injector application is a gas injector, then it is highly recommended. The two-phase version is the most common one. 90% of the time, this version is used. We have already covered this one. It does measure velocity and speed of sound, and it comes with an integrated PT gauge. It is good for two-phase applications, liquid-liquid, gas-liquid, gas-oil, gas-water, gas condensate, or sometimes it can be used for one-phase dominant two-phase flows as well, such as gas-rich liquid flow, as in gas producers, or gas-liquid-rich flow, like the oil producers. And it is possible to use a two-phase flow meter in a single-phase injector applications without any issues. The three-phase version is similar to the two-phase one, except that it does also include a secondary PT gauge, preferably installed with some vertical distance. As we have covered in an earlier section, that vertical distance is needed to have the hydrostatic term so that we can calculate the density for three-phase calculations. However, it is also possible to install the three-phase flow meter in a completely horizontal way. Even the secondary PT gauge can be horizontally installed, as long as that secondary PT gauge is installed far away from the optical flow meter. Now, there is one limitation on the gas end. The gas volume fraction can be 30% or lower for this three-phase flow meter. For a given application, whether the three-phase flow meter is feasible for that application or not needs to be determined on a case-by-case basis. Whether the secondary PT gauge needs to be installed vertically, or if it is going to be installed horizontally, how far away it's going to be installed, it will all need to be determined on a case-by-case basis. Again, this three-phase flow meter can be used for single-phase or two-phase applications as well. Now, the optical flow meter can also be built for some extreme situations. For example, for liquid-liquid flows, these flows sometimes are very quiet. The valves are very quiet, and it may be challenging to measure the speed of sound. So for those applications, it is possible to build the optical flow meter in a more sensitive way. On the other hand, for some applications, the valves could be very noisy. It could have high acoustics. For example, in the case of the inflow control valves, where those valves are actively used. There may be very high acoustics. So for those applications, it's possible to build the optical flow meter in a more acoustic tolerant way. So let's move to the next slide, to the optical configurations. So normally, a fiber cable comes with 3 or 4 fibers, and each of these optical fibers can support a variety of monitoring combinations. For example, a single mode fiber can support 3 PT gauges. Another single mode fiber can support 2 PT gauges and 1 flow meter. This is exactly the configuration for a 3-phase flow meter installation. It is also possible to have a multi-mode fiber and dedicate that to distributed temperature sensing measurements, DTS measurements. The optical flow meter, PT gauges, and DAS can be on the same fiber, providing that the wavelengths are different. There is an ongoing effort on the DAS instrumentation and the optical flow meter. It is possible to use the optical flow meter with the DAS instrument. So those two can be combined. So with that, we have reached the end of chapter 1 and completed our task of introducing the technology of the optical flow meter.